So here we go. I think the actual grind it out on your calculator part isn't going to be too hard because we'll practice it and that part's going to be easy. But I'm going to try to hit you with a few questions that are not getting the number, but like what does that number mean? Okay, so let's say you had an R value that was negative 0.5. Do you even know what that means? I'm going to give you some context. Let's say it's about age over 25, because as you get from 25 on, something happens to you. And this is strength. If R is negative 0.5, what does that mean? Take a second and write down. You should use 2 words that tell you a lot about negative 0.5. Did you remember it was correlation? That's what that is. Maybe you should write that down. The correlation is, first of all, negative. Why is that important? Because strength and age are not perfectly correlated, but they are correlated. They go down. The older you get, you don't see any 90-year-olds setting records on, like, the Olympics. All right? People in the Olympics, if you're even still doing the Olympics at 25, that's amazing. Usually the Olympians are in that neighborhood a little younger. All right. And what else could you say besides the correlation is negative? Was it strong? Was this strong? How do you judge? Well, strong would be about 1. Is it a 1? No. So it can't be strong. This is right in the middle. So you wouldn't call it weak. What would you call it? Moderate. How do you judge? Well, if you had like anything between 0 and 0.3, that's going to be the weak end. Between 0.3 and 0.67, we're not going to ever get this close, but it's about thirds. Then it's moderate in the middle. You don't have to use the word moderate, but you have to somehow say it's not weak and it's not strong. So I guess moderate is the best word for that. And then if it's in between 0.67 and 1, it's strong. All right, so this was moderate negative correlation. So is it true that as you get older, your strength goes down? Yeah, that's the point. It's the negative thing. All right, let me give you another one where it's just a picture. Your calculator can't save you on this one. Can you tell me on this, from these data points, what could you say about the correlation? The R. I know you can't tell me exactly what R is, but you should be able to tell me something about R. And if you're like, I can't even tell if there is a correlation. If I draw a line through it, I think you'll see. There's a correlation there. And it's definitely going up. So you should have been able to say that this was weak or maybe moderate. It'd be really hard to argue which one it is between weak and moderate. Positive correlation. But it's definitely going up. It starts out low, ends up high. You know, it's going up. So that's positive. Now, how strong is it? That's kind of a hard judgment call. It is definitely not strong, though. Otherwise, they'd be right in a line. Okay. One more thing that's not about, can you get your calculator to do it? This is about, do you understand the difference? Okay, there's mean and there's median. Give me a one-word description for what they mean. What does mean mean? And what does median mean? And they clearly are different, but what do they mean? You don't have to give a full fancy definition, but you have to know the difference. You writing these down? Because we're going to ask you if you know the difference between these. And there's a lot of ways we could ask you the difference. One would be for a one-word description. Can you tell me what's a one word for mean? Average. Good. How about one word for median? That sounds good. Make sure you watch this video. Okay, middle. Good. Somebody said middle. Mean was average. Now, is that enough? Not necessarily. Let's see if you can tell the difference here. So there's five houses in your neighborhood. You live on a cul-de-sac. I know you don't all do that. Somebody probably does. There's 5 houses in the neighborhood, okay? And you mostly are kind of about the same when it comes to socioeconomic, like how much money your family has. And, you know, it's not like super high. You add up the value of your house and your cars and all that stuff. Well, one person moves out of your neighborhood and a new person moves in, and that new person invested in crypto when crypto was just coming online. All it would have literally taken is a few $1,000s buying Bitcoin, and that could be a billionaire right now, literally. I just kicked myself because I saw it coming, and back when they were $200 each, I was sitting in this, maybe not this room, but one of the rooms in this school, and I was going, man, $200? That seems like a lot for this fake currency that's online. That's probably just a scam. You know what they're worth now? 100,000. That's like enough to buy a really nice Porsche. And I could have got them for $200 each. How many would you like at $200 each? As many as you can get. And that was it when they were $200 each. You know, when Bitcoins first came out, they were like 25 cents each. In fact, when they first came out, they were less than 25 cents each. And now they're worth $100,000. Like 10 Bitcoins to get you a nice house on Lake Minnetonka. And you could have got them for like a quarter. Okay, so again, it's kind of crazy, but this video is going to go online, and there's a chance that one of you is going to re-listen to it in 10 years, and you're going to be like, Bitcoin was only 100,000 back then? Because I know people who say that Bitcoin's going to be $1 million each, and 100,000 would be cheap. Maybe you can't buy a whole one, but you can buy parts of Bitcoins. All right, I'm not saying that they're going to go up like that. I don't know. Maybe they'll crash and be worth nothing. There's a chance of that too. But the point is, somebody has moved in and they are a billionaire. And let's just keep it simple. Everybody else's net worth was about 100,000, which is a lot less than $1 billion. This is net worth, just means basically if you add up all the stuff you have and you subtract any debts that you have, that's how much you have left. That's your net worth. I want to know what happened to the average in your neighborhood. After the rich guy moved in and bought Bitcoin, what happened to the average and what happened to the median? It's very different. Did you know that the average could go way up because you have to add in $1 billion now and then divide by 5? Okay. And did you know that the median wouldn't even change? No change in the median because the middle person is still at 100,000. All right, so averages aren't a terribly bad thing. It's just they can be thrown off by like one person. I'll give you another example of that. I saw the average person who's got a 401k. This is the thing you use to save for retirement. The average 401k was like $500,000. It's like, holy cow, super high. And you know what the median 401k was? About $50,000. Doesn't that make you think if the, oh, I said median, sorry. Doesn't that make you think, like, wait a minute, those are completely different signals you're sending there. This makes it look like the middle person has about 50,000 saved for retirement. That's not like a crazy amount, but it's, a decent amount. And this one makes it look like everybody that's got a 401k is rich because the average is 500,000. The difference was insane. It was so much bigger average. Why? Because there's a few people that literally bought things like Bitcoin or things that could go up crazy amounts. And so some people's IRA or 401ks, which you can invest in things, some people had made really amazing investments and had gone up a ton, and other people, most people, did not. And so the average and the median are so different. One of them makes it look like, yeah, every American's rich. The average one has $500,000. And then this one makes you think, well, okay, so they got some money saved for retirement, but not that much. You can look up those exact numbers sometime, and you'll see they're hugely different because there's outliers. And again, there's some luck involved. If I would have taken the time on that one day when I was looking at Bitcoins at $200 each, part of the problem was I didn't know how to buy them. You can't just like go down to the store and buy some. So I would have to figure out, how do you buy Bitcoins? And where do you go and where do you put them? And if I would have taken literally, I bet you I had taken 2 hours that day, I could have figured out how to buy them, bought a bunch, and then I'd be like probably 100 millionaire right now. Seriously, crazy. But I was a teacher right here in this school, had that choice. The real trick is what's happening right now that everybody's just ignoring, and it'll be a huge deal 10, 20 years later. And I think most people are underestimating the whole robot thing, but I won't get into that. I think there's going to be so many robots walking around when you're my age. They're going to be everywhere. And that's going to change everything. When you get labor that's $3 an hour and is stronger and better than humans are, it's going to change everything. Okay, so let's say you had a box plot, and here's a box plot, and it's got 10 here, 20 here, 23 here, 30 here, and 45 there. Would you be able to tell me the name of all 5 of those spots? You gotta know that. All 5. Next, I'd like you to write this one down, and just take you a second to write it down, and then give that little 1-word or even letter description of these. There's like a 2-letter description for some of them. And then I'm going to ask you some questions about the box plot. There's a lot of box plot questions, so pay attention to this part. All right, did you know this is the min? Did you know this is the max? Did you know this is the Q1 and the Q3, and then this is the median, not the average? Okay. Then, that's 5 questions we could ask you. They're probably not separated out into 5 separate questions, but here's another question we could ask about this. What percent of people are between here and here? Say it. 50%. 50%, yep. They're in little sets of 25. What percent of people are between here and here?
50.
Nope.
Oh, 75.
25, 25, 25. 75%. Okay? All right. Then there's this kind of question. What kind of curve is that? The bell curve, the normal curve. All right, let's say this is shoe size in here and the average shoe size was a 10. And let's say I gave you this weird looking little symbol. What's that stand for?
Sigma.
Yes, it's sigma, but what does it stand for? Not the average, nope. The average is the X with the bar. That's average. Come on, somebody. Good we talked. Everybody write this down. Standard deviation. Okay. So have you got this copy down? This is a really big one. Like I said, the box plot's got like tons of questions. So does this. Lock in, everybody. Only got about 10 minutes left. You're done with the review for this test. These last 10 minutes are big. Okay, so what are those two marks? You should be able to not tell me the numbers. Those are not Q1 and Q3. That's completely different. You should be able to tell me what number goes in those two circles. Welcome back. As long as I get a pass from the counselor, we'll be good. All right, now, I have to tell you something to get this. If the average shoe size was 10, what do you also have to know to be able to get these? What haven't I told you yet? Man, you guys suck at this. Okay, pay attention. You need the standard deviation. So if the standard deviation is a 2 point, now let's just call it a 2. The standard deviation is a 2. Now you should know what goes here and what goes here. Pay good attention. Like I said, this is a big part of your test. These normal curves. The bell curve. Okay, and then you should know that this is one standard deviation bigger, which would make it 10 plus the 2 makes 12. Who had a 12 in there? Okay, good. I was losing hope in humanity for a moment there. Now I'm going to subtract 2, and this one will be 8. And then we could ask you this question. Do you remember those little charts that we give you that tell you what percent is in each spot? I would love it if somebody would just remember these 2%. You remember it, Nicholas?
Is it 14.5?
Nope. Nope. Thanks for trying. Remember? It is 34% here and 34% here. We'll give you that chart. The next one's 13.5. And 13.5 goes here. And there's more, but I'll just give you those. If I give you this chart, like I just did, what percent of people in here have between size 8 and size 12 shoes? Isn't that just from here to here? Yep. 68%. Raise your hand if you had 68%. Okay, awesome. Did you get that part? So between those two lines, it's 68%, because you just add up the 34 and the 34. It's 68% of people. Yes?
So when we ask those questions, what are we going to be given?
We're going to give you something like these numbers here. Or maybe we just give you this number and this number, and you'd be able to make the 12 and the 8, right?
And then is the 13.5 and 34, is that all going to always be the same?
Yes.
The number you said that we should probably memorize.
If I was going to have you memorize something, it would be the 68% went from here to here, because then you could always split it in half in your head and know it was 34 and 34, right? But I just think in the real world, it's smart to know these. You look like you're really smart if you know it's 68, 95%, and the third one is if you go out 3 standard deviations, this is like, you'd be like, holy crap, you knew that is 68, 95, and 99.7? Because that's like one of the things that the stats majors know off the top of their head and use all the time, and it's just a good thing to know. 68, 95, 99.7. All right, then you'd have to take, you do not have to memorize those. I just suggested that it was good if you'd memorize them. The reason you don't have to memorize it, we're giving you this chart. You can just add these together and get 68. And if you add up all of these, you get 95. And then if you add up all of them, you get 99.7, and then the little cutoff ends must be less 0.3 then, I guess. Okay. Okay. And last one. What percent of people are between 9 and 15? 68. Good. What would these numbers be? Do you get what to do?
Is it 18?
Couldn't you figure out that this would be 12 because it has to go the same in each direction? You get that? That's what I do first. And then do you realize it's adding 3, and every time you go over a line, it's adding 3, right? 9, 10, 11, 12, 13, 14, 15, so this must be 16, 17, 18, and this must be 6. See what I'm saying? And then I could say, what percent of people are in here? Between 9 and 18. And be like, you've never done that one before. Well, you know it's 34% and 34%. You'd have that on the chart. Who's got a good short-term memory and remembers this number?
13.5.
Very good. You just have to add those up, and you'd be able to tell me what percent of people are between 9 and 18. Okay. All right. Last thing. We're just going to put in a few numbers on your L1 and your L2, because then we can do the linear regression. Last problem. Okay. So go to your lists. This is under stat. We're going to go with 8 and 18, 12 and 22, 11 and 16, and 13 and 23. Put in those numbers on list 1 and list 2 and delete anything else you have in there. I usually start by hitting DEL until I've deleted every number that's in there. Okay, stay locked in. We got 5 minutes left. Less than 5 minutes. Type these all in because there's several questions about lists like this. Okay, now, would one var stats be appropriate for this? Is there only one variable? No, we got 2 variables. So, you don't do one var stats on this kind. Everybody go out, after you've entered them, raise your hand if you've entered them. Raise your hand if you're there so far. Okay, good. So now, we're going to go to calculate, stat calculate, something that's not one var stats. That'd be only if they gave you one set of numbers. What's the other thing we did? Don't say it. Do it. Use your calculator. Figure out what stat calc did we do on this kind. Take a second. Type them in. Do this. It's your test score. I'm just trying to encourage you. All right. So the one that we did was called LinReg, and it's short for linear regression. And if you do that and you hit enter a bunch of times because you're going to use list 1 and list 2, if yours is not telling you this, y equals ax plus b, and then a is 1, And B is 8.75. And R squared we never use. R is 0.65. Good enough. If you didn't get that, then you got to come up and ask or something, because you need to know how to do a linear regression. What can you say about the correlation? Was there correlation? Yes. Was it strong? It's right on the edge of strong. It's right between strong and moderate, so we probably wouldn't even use this one because it would confuse too many kids. Would you agree that it's positive correlation? Okay. Remember, this is like right on the borderline. If I'd have made it 0.8, you'd have known it was strong, wouldn't you? And if I'd have made it 0.5, you'd know it would be this kind of like in the middle, moderate. Okay. All right. And then what's the actual equation? Take a second and write it. It always starts with y equals. What's the actual equation? We have 2 minutes left. I have 2 more questions, and they are all critical things you have to know on your test. So stay locked in here, right? Y equals, what is the full equation? Well, I'm going to have you round it to a 1 decimal place. 1 decimal place. Like after the decimal, you'll have 1 number after the decimal. So 1x plus 8 if I have to round to 1 decimal place, 8.8. Raise your hand if you had that right. Awesome. Now I'm going to tell you what they were. This was study time. Let's say it's for your final. Do you get, if somebody locked you in the room and made you study super intensely for like 8 hours, you would do awesome on the final. 8 hours of study, holy crap, that would make you so good at it. Probably get an A for sure. Probably some of you a perfect paper. And this is your grade. Now I know some of you are thinking 22 is a grade. Well, what if there was only 22 questions on the final? Okay. So, study time versus grade. Now, what if I said the grade that the kid got was a 20? They got 20 on the final. Would you know what to do with that? Nichols, there's 2 places that people could put that 20. Tell me what they are. One of them's right and one of them's wrong. But tell me the 2 places you could put the 20.
X or Y.
Yeah.
My one's correct.
It has to either go here or here. There's only 2 places that are variables. And the grade was the L2, which is the Y. You have to be able to put that all together. That was the second variable, which is the Y. And so that is where the 20 goes. So it goes there. If you're like, I don't know how to solve that. Well, we've solved equations like this since the beginning of the year. You'd subtract 8.8 and you divide by 1, which doesn't really do anything. So final answer is whatever 20 minus 8.8 is. Pretty sure that's like subtracting, it would be 11.1. Raise your hand if you had 11.1. Isn't it? Or 5. 11.5. Sorry, 11.5. Subtracting 8.8.
I think it's 11.
Oh, it's 11.2. Dang it. I'm trying to do it in my head. Should have just used my calculator. Yeah, I can do that one. Yup, there it is. 11.2 equals x. There we go. Who had 11.2? Okay, good. Okay, cool. You made it to the end. Now, is your studying done? No. But there's a worksheet, and that worksheet, I'm gonna tell you what 2 problems to skip, but I have one last favor to ask of you. The principal has required every single teacher in this school in the month of May to ask their kids to fill out a survey about them as a teacher. Now, sometimes I just do these because I want to know. This time, the principal is saying, you must, every teacher in the building must have the kids fill out a survey about them in May. So, would you please look for the link called survey? I have to do this. And I really want you to be honest. I'm not afraid they're going to fire me. Like, I just want you to be honest. I think I'm doing a good job overall, but I know there's things I could do better, and you could tell me what they are. So I'm gonna leave one last thing in the notes here, and I'll leave it written on the board. For today's homework, you're gonna skip number 2 and 5. I'll leave this up on the board. Thank you for filling out that survey. I really appreciate it. And that's all I got for you for today.